Quiz 5 solutions for Math 95. In this first one, we're given an absolute value inequality. Several ways you can solve this, but the one I taught you is to first change it to an absolute value equality. That is, change it from a less than sign to an equal sign. Makes it easier. Changes the problem, makes it easier. We'll have to make up for that later, but it's a good first step. So really the challenge here are these absolute value symbols. I want to get rid of them. The easiest way to get rid of them is to have them isolated. So the way I will isolate them is I'll subtract 5 from both sides of the equation and get to here. And now I got the absolute value symbols all by themselves. And you can get rid of the absolute value symbols when they're all by themselves by kind of considering two cases. So the challenge is if I knew what was inside the absolute value symbols were a positive number, if I knew that. I don't, but if I knew that 2x plus 2 was positive, then I wouldn't even need the absolute value symbols because I wouldn't be doing anything, right? The absolute value of a positive number is just that number. So if 2x plus 2 happens to be positive, I can rewrite this equation as 2x plus 2 equals 11 minus x. But I don't know that, right? It's also positive. It's also possible that what's inside the absolute value symbols is 2x plus 2 is a negative number. Since I don't know what x is, I don't know what 2x plus 2 is. If this thing is a negative number, then what the absolute value symbols do is they change the sign of that number. In other words, another way of mathematically saying change the sign is they take the number that's inside here, I don't know what it is, but it's some number, and they multiply it by -1 to change it from being a negative number to a positive number. Essentially, it changes your equation into this. If this is negative, it's now positive. I get two equations. Solve those two equations. They're easy to solve because there's no absolute value symbols. On this one, we'd add x to both sides, get 3x plus 2 equals 11, and then subtract 2 from both sides and get 3x equals 9. Divide by 3, we get x equals 3. Over here, I want to do something similar. I want to combine like terms. Can't really do it because of the parentheses, so let's first take the negative and distribute it through the parentheses. Then maybe add 2x to both sides. And then subtract 11 from both sides, and we get these two solutions. But these are not the solutions to the problem. These are the solutions to this equation, what we turn the inequality into. Essentially what these are the boundary points that will help us figure out the intervals that are solutions up here. So what I'm saying is take these two values, -13, somewhere over here, and 3, and use them to divide the number line up into 3 different regions. It's time to change colors. Here's one region, everything to the left, everything less than -13. Here's a second region, everything between -13 and 3. And finally, here's my third region, everything greater than 3. And the nice thing about these regions is if one number in this region, any number, satisfies this inequality, then all numbers in the region will satisfy the inequality. So all I got to do is test any number that's less than -13. Ugh, it's kind of an ugly number. Test region 1. Maybe I'll let x equal -20. All right, that's certainly less than -13. Let's see what happens. The absolute value of 2 times -20 plus 2 plus 5. We want to know, is that really less than 16 minus -20? Well, 16 minus -20 is the same as 16 plus 20, which is 36. And over here, I got the absolute value of 2 times -20 is -40, plus 2 is -38. I think this is going to work, but just barely. So the absolute value of -38 is +38. And 38 plus 5, yeah, that is not less than 36. Right? 38 plus 5 is 43. So 43 is not less than 36. So what that means, maybe no, I don't know what to write here. So what that means is these numbers are not solutions. Now we go through and do something similar for region 2. Let's test region 2. Pick any number in region 2. Instead of -20, how about 0? Right? That's a number between -13 and 3. So let's see, the absolute value of 2 times 0 is just 0, plus 2. That thing plus 5, we want to know, is that less than 16 minus 0? Well, sure, because the absolute value of 2 is just 2, and 2 plus 5 is 7, and 7 is less than 16. So yeah, it looks like that does work. In other words, all these numbers work. What about region 3? Maybe I'll put it over here because I'm running low on room. Any number in region 3, any number that's greater than 3. I don't know, 5? Sure, it's easy to multiply by 5s. Let's make x equal 5. Then I would have the absolute value of 2 times 5 plus 2. And then to that I want to add 5, and my question is that, whoops, not equals 2. Is that less than 16 minus 5? Well, let's see, 2 times 5 is 10, plus 2 more is 12, and the absolute value of 12 is just 12. So the question is, 12 plus 5, is that less than 16 minus 5? It's not, because this is 17 and this is only 11. So this is not true. No. I don't know if the exclamation point is absolutely necessary, but whatever. This is not true. 5 did not work. If 5 doesn't work, that means none of the numbers in this region work. So the only numbers that work are the numbers in region 2. So solution is, let's see, it says in interval notation. So I want all the numbers from negative 13 up to positive 3. What about those endpoints? Do you want to include those or not? Well, you go back, I'm asking you a question like you're going to answer when I'm talking on YouTube. You don't want to include those because this just says strictly less than, not less than or equals to. So you don't want to include those endpoints. We'll put parentheses instead of brackets and call this up here our final answer. And we're only done with one of the two. Fortunately, that one's a lot harder. These are pretty quick. The first one here, A, the square root of negative 16. This is undefined. Why is that undefined? There is no number, no real number, that when you multiply it by itself, you get negative 16. No real number times itself equals negative 16. All right, 4 times 4 is positive 16. Damn. Oh, but what about negative 4? It doesn't work either, because negative 4 times negative 4 is also positive 16. A negative times a negative is a positive. This is undefined. What about this one? It's the same. Well, not quite. This one I'm taking the square root of negative 16. And this one I'm taking the square root of 16, which is totally fine, and then saying my answer is the negative of that. So my answer here is going to be negative 4, and you don't need to write y. But parenthetically, I'll say because the square root of 16 equals 4. Why is the square root of 16 equal 4? 4 times 4 equals 16. Yeah, negative 4 times negative 4 also equals 16. But the square root of 16 we're defining as 4. This is called the principal root. I won't get too far into that. For our purposes, the square root of 16, any square root, your answer is always going to be positive. So we get 4 here. And then the negative of positive 4 gives you negative 4 for our final answer. What about this guy down here? The cubed root of negative 8. Oh, you can't take the root of a negative, right? But you can't take the even root of a negative. You can take an odd root of a negative. In fact, in this case, my answer is going to be negative 2. And the reason that's true is negative 2 times negative 2 times negative 2. If you multiply these three things together, 3 of them, because we're cubed root here now, negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. And then finally, negative cubed root of 8. Turns out that one's also negative 2. And the reason why is because the cubed root of 8 is just equal to positive 2. That's 2 times 2, times 2 is equal to 8. So 2 times 2 times 2 equals 8. So the cubed root of 8 equals 2. But this is not asking you for the cubed root of 8. It's saying what is the negative of the cubed root of 8? Well, the negative of 2 is negative 2. So my answer here would be negative 2. And that would be the end of the quiz.